Okay, so this video is about derivatives. First of all, derivatives is a calculus concept, but we use it in this class because it's really useful in finding local mins and local max of polynomials. So that's why we're talking about it. But again, what are derivatives is the first question you might be asking. What are derivatives in the first place? And what they are, basically derivatives have several names. Derivatives have several names. And one name for a derivative is slope of a tangent line. So you ever hear slope of a tangent line, that is synonymous with derivative. More importantly, first derivative. So if you ever hear instantaneous velocity, that is also synonymous with the first derivative. Instantaneous in this case meaning that instant in time. So if you want to find the velocity of a rocket ship at a specific instant in time, you'll take the derivative or the equation for the speed of that rocket ship, and that can tell you the speed at any given time. And another word for a derivative is instantaneous rate of change. Should make sense because rate of change, you know from early algebra classes, rate of change just means slope anyway. So they're the same thing. So instantaneous rate of change, instantaneous velocity, or instantaneous or slope of a tangent line. All three different names for first derivative. There's a second derivative too, just so you know. The second derivative has a name, and it is called the instantaneous acceleration. All right, so instantaneous acceleration. Meaning that if you want to find the acceleration of that rocket ship, not its speed, but how fast it's accelerating, you'll take the derivative of that speed equation and then take the second derivative of that equation, and that will lead you to the instantaneous acceleration of that rocket, how fast it's actually accelerating at that instant in time. So anyway, all those are different names for derivatives. I would pause the video and copy all this down because I'm about to erase the screen. You won't have it anymore. So right now, go ahead, pause the video, copy everything you see, because in a second, it's going to all be gone. All right, so I'll pause it now. All right, so let's actually talk about how to find a derivative. So this is how I would find a derivative. If I was trying to find a derivative, I would basically do this. If this is the equation, let me block this also. I got more space. It's not all together. If this is the equation, to find the derivative of this equation, you take the derivative of each term in that equation. So this is y. The derivative of it is y prime. That little apostrophe there means prime. Prime. Anyway, it's represented by one apostrophe. If I want a double prime, it'd be two apostrophes. Anyway, so this says y prime. That means first derivative. To take the derivative of this first term, this is the first term, I would take the 3 multiplied by the 2, the coefficient, and then subtract 1 from the exponent. So basically you take the exponent and just multiply it there. So it's 3 times 2 is 6. Then you subtract 1 from that exponent. So if you reduce the exponent by 1, it becomes squared. And then the next one now, I'll take 2 multiplied by the 4, making 8. Reduce that exponent by 1, leave me x to the first power. In the next one, there's 5x to the first. So this is an understood 1 here on the exponent. So I'll take the exponent and multiply by 5, and then subtract 1 from the exponent. So you get x to the 0 power, which we know is 1, because anything to 0 power is 1. And the last one is 7. The derivative of a constant is determined without a variable next to it. So the derivative of a constant is always 0. So I just know the last number is 0. So that's the derivative of it. You might say, well, why is it 0? Well, that's a good question. The reason why it's 0 is if I gave you 7, that's really 7x to the 0, right? Because 7x to the 0 means 7 times 1, which is still 7. So if I began with 7, it could be called 7x to the 0. And equals that. So anyway, so if that's the case, it's equivalent to what we began with. So if I actually gave you 7x to the 0, and I said, take the derivative of 7x to the 0, well, you know you would take the 0 and distribute to the 7, making it 0. And then you subtract 1 from the exponent, making it 0, and then x to the negative 1. And 0 times anything, still 0. So that's the reason why the derivative of a constant is 0. All right, anyway, so that's it. If you think you understood everything I said about finding the derivative, you can pause the video and try this next one. If it's kind of still confusing, stay with me. I'm going to explain the next one. So here's number 2. So number 2 says y equals this. So y prime equals to, I'm going to take 5 and multiply by 7, making it 35. Then subtract 1 from 5 to make x to the 4th. And then I'm going to take the 1 that's understood to be here, multiply to the 9, making it 9. And there's going to be x to 0. Subtract the derivative of 14 is just 0. So that's what the derivative of it is. We could clean it up a little bit though. Like, I really don't like looking at 9x to the 0. I'd rather just go call it 9. And I don't really write or subtract 0 on the end unless I just have to. So I'd rather you clean it up and call it y prime is equal to 35 x to the 4th subtract 9. Why? 9 times 0 is 9. And for that matter, this could be cleaned up, and it could be called y prime equals to 6x squared plus 8x subtract 5. And that would be a more simpler looking, cleaner looking answer. So anyway, that's the derivative of the first one, and that's the derivative of the second one. If I give you some more, I'm going to switch it up a little bit by giving you fractions and that kind of stuff, but that's the basis of it. So whenever you're confused, that's what you're going to be doing. I will pause the video and copy anything you find necessary as a note, because I'm about to erase the screen again. All right, so these 2 examples said find the derivative of each equation. If you think you know how to go forward, pause the video, try it on your own, and see if your answer matches mine when you get finished. Because I'm not going to tell you very much new. It's really just using what you understand about integers. So anyway, if you think you got it, pause it. If you don't think you have it, here we go. Let's talk about it. All right, so this first one, y prime, I'll take -2, multiply to 3, making it -6. Then x, I'll subtract 1 from -2. So -2 subtract 1 is -3, plus -1 times 5 is a -5, and then it's x, subtract 1 from that gives you -2, plus 1 times 9 is 9x to the 0, plus the derivative of 3 is just 0. So a nice looking answer would be -6x to the -3 plus, better yet, let's go call that plus sign subtraction. So subtract 5x to the -2 plus 9. And that's what it is. Now, technically, we know that x to the -3 is really a fraction, because typically we write the negative exponents on the bottom of fractions. So you could see this answer as -6 over x to the +3 subtract 5 over x to the +2 plus 9. So again, these negative exponents means they really belong on the bottom of fractions. Anyway, we'll talk about more of that later. Going into the next one. If you try this one, you should take the derivative of the first term. So it's going to be y prime equals to -21 x to the -4 plus 0. Subtract 0. And that's what the answer is. All right, so that's how you take derivatives. That's how you find derivatives. Let's actually go a little further. Let's actually find a second derivative. So let's say I actually gave you the derivative of that. I said find the second derivative, just for fun. Second derivative of this, you basically take the derivative of the derivative. So we already have the derivative, and I would take the derivative of it by taking 4 and multiplying it here. So -4 times -21 is a +84. And I'll subtract 1 from that, gives you -5. Derivative of 0 is still 0. I'm not going to keep writing that 0. This would be it. So that would be the second derivative, had you need to find the second derivative. If you want to find the third derivative, what do you think you do? Well, yeah, you just take the derivative of the second derivative. All right, so that's all it is to it. I will get anything you need as a note, because I'm about to erase this screen, put up more. All right, last 2. You can try them on your own first if you think you understand it, or you can just wait for me. If you think you understand it, or pause the video, try it now. If not, here we are. All right, so looking at the first example. Personally, I would not leave it as a fraction. It's going to make problems happen. So I would rewrite every one of these fractions with negative exponents. So this really means y equals to 1x to the negative 2 plus 4x to the negative 3 plus x. So whenever you have negative exponents, you can do that. You can just, whenever you have x variables on the bottom, you just bring them up to the top with whatever was on top as a product with a negative exponent there. So then now to get it there, I'll take the derivative of that. So the derivative of that is pretty easy. I would call this negative 2x to the negative 3, subtract 12x to the negative 4 plus 1x to the 0. Yeah, it's a 0. And because they began with fractions, now that I found my derivative, I will go put it back in the fractions. So I'll go call that y prime is equal to negative 2 over x to the positive 3, subtract 12 over x to the positive 4 plus 1. All right, so that's it. Not much to that. So if you think you got it now, you can pause it now. Try the last one. I'm going to show the answer to it though, if you haven't paused it. So this should be 3x to the negative 1 plus 5x to the negative 2 plus 1x to the negative 3 plus 4. And the derivative of it, first derivative of it, should be negative 3x to the negative 2, subtract 10x to the negative 3, subtract 3x to the negative 4, plus 0. Or, as fractions, y prime would be negative 3 over x squared, subtract 10 over x to the negative 3, oh sorry, x to the positive 3 now. We move to the bottom, subtract 3 over x to the 4th, and that's it. All right, so that's all I can tell you about the basic how to find derivatives. Hopefully you have a decent understanding of it. We got one more thing to talk about, so pause the video and copy down everything so as a note. All right, last example, I'll pause the video and copy down this note. It says find the slope of the tangent line that passes through x equals 3, given the equation y equals x squared. So we know what that equation looks like. That's a parabola if you graph it. It looks something like this. And it says when x equals 3, so let's say 3 is here. We want to know the slope of the tangent line there. So again, the tangent line just barely touches that equation. You want to know the slope of that place. So basically what you do is you take this equation, take the derivative of it. So 2x to the first. Then after you find the derivative of that equation, to find the slope there, you evaluate 3 into it there. So I will get 2 times 3 to the first, which is 6. So y prime at 3 is 6. So that means the slope of this line right here, m equals 6. So apparently that line has a rise of 6 and a run of 1. But yeah, that's how you find the slope of it. You just take the derivative of that equation, then plug in 3 at that point. All right, give you a new example. All right, so the new example says find the slope of the tangent line at x equals 1. Assuming you have the same equation, so 1 would probably be around here. And if you want to find the slope of the tangent line there, you still take the derivative of it. So if I have y equals x squared, the derivative of it would be 2x to the first. I'll plug in 1 for the x, so y prime equals 2 times 1 to the first, or just 2. So apparently the slope there would just be 2. The whole purpose of learning this is finding these local max and min, which is later. So eventually you want to find out when that slope is 0. But right now, this is all you need to know, how to find the derivative and find out the slope at any specific point. That's all I have. Good luck.